Most developers hear terms like API key, JWT, OAuth, bearer token, session authentication, OpenID Connect, or single sign-on, and they often assume they all mean the same thing, but they don't. Some of these describe how credentials are sent over HTTP, some describe how login state is managed, some are token formats, and others are full identity protocols. The easiest way to understand authentication is to walk through how these methods evolved over time. Let's begin with one of the earliest approaches, basic authentication. Basic authentication is one of the simplest ways to authenticate a request. The client sends a username and password with every HTTP request using the authorization header. The credentials are encoded using base 64 and attached to the request. Because base 64 is just encoding and not encryption, anyone intercepting the request could decode the credentials if HTTPS is not used. This simplicity made basic authentication popular in early APIs and internal systems, but today it's rarely used in production environments because repeatedly sending credentials is risky. To improve on that idea, digest authentication was introduced. Digest authentication works using a challenge-response mechanism. Instead of sending the password directly, the server first sends a challenge to the client. The client then generates a hashed response using the password and the challenge value. The server verifies that hash instead of checking the raw password. This prevents the password from being transmitted in plain form. While it is more secure than basic authentication, it is also more complex and not widely used in modern systems because newer token-based approaches are easier to scale. As web applications became more common, a different approach emerged: session authentication. Session authentication is the traditional login mechanism used in many websites. When a user logs in successfully, the server creates a session that represents the authenticated user. The server stores that session and sends a session ID to the browser, usually through a cookie. On every subsequent request, the browser automatically sends that cookie back to the server. The server reads the session ID and knows which user is making the request. This approach works well for server-rendered web applications, but it requires the server to store session data, which becomes harder to manage when systems scale across multiple servers. To avoid storing login state on the server, modern systems often use tokens instead. One of the simplest token mechanisms is the API key. An API key is a unique identifier assigned to a developer or application. The client includes this key with each request, so the server can identify which application is calling the API. API keys are commonly used for public APIs, such as maps, weather services, or payment integrations. However, API keys usually identify the application rather than the individual user, so they are often combined with other security mechanisms. As APIs and microservices became more common, another concept became widely used: bearer tokens. Bearer authentication means the client sends a token in the authorization header with the format authorization:bearer. The word bearer simply means that whoever holds the token is allowed to use it. The server verifies the token and allows access to the requested resource. This method is widely used in modern APIs because the server does not need to store session state. However, bearer tokens must be protected carefully because anyone who obtains the token can impersonate the user until the token expires. Many bearer tokens today are implemented using JSON Web Tokens, commonly called JWTs. JWT is not a protocol, it is simply a token format. A JWT contains information about the user in a structured JSON payload. The token is digitally signed by the server, which ensures that the data inside the token has not been modified. Because the token contains the information needed to identify the user, the server can verify requests without querying a database every time. This makes JWTs very useful in distributed systems and microservice architectures. When tokens are used in real systems, they usually come in two forms: access tokens and refresh tokens. An access token is used to access protected APIs. These tokens are intentionally short-lived, often lasting only minutes or hours. If an access token is compromised, the attacker only has a limited window of time to use it. A refresh token is different. It is longer-lived and is used to request a new access token when the old one expires. This allows applications to maintain a user's login session without forcing them to repeatedly enter their credentials. As applications started integrating with other platforms, another technology became essential: OAuth 2.0. OAuth is an authorization framework designed to allow applications to access resources on behalf of a user without ever seeing the user's password. For example, when an application asks for permission to access your Google Drive or GitHub account, OAuth is typically used. The user authenticates with the external provider, and the application receives an access token that grants limited permissions. OAuth focuses on authorization, deciding what an application is allowed to access. However, OAuth alone does not provide a standardized way to verify a user's identity. That's why OpenID Connect, often called OIDC, was introduced. OpenID Connect builds on top of OAuth 2.0 and adds an identity layer. It introduces something called an ID token, which contains verified information about the user. This allows applications to confirm the user's identity without managing passwords themselves. Modern login systems such as Sign In with Google or Sign In with Microsoft are typically implemented using OpenID Connect. Finally, many organizations implement Single Sign-On, or SSO. Single sign-on is not a specific protocol, but a user experience. It means the user signs in once and gains access to multiple applications without logging in again. For example, when you log into your company account and automatically gain access to email, dashboards, and internal tools, that is SSO. Behind the scenes, identity protocols such as OpenID Connect or SAML make this possible. When you look at all these concepts together, authentication starts to make much more sense. Early systems relied on simple credential-based methods like basic authentication. Web applications introduced sessions to manage login state. Modern APIs shifted toward token-based authentication. OAuth enabled secure access between applications. OpenID Connect added identity verification, and SSO created a seamless login experience across multiple systems. Understanding how these concepts fit together allows developers to design authentication systems that are secure, scalable, and easy for users to interact with.